Everything counts in large amounts. That was important, okay? So, welcome. In this session, we are fighting database applications, and it's not clear, is it about performance and is it about security? Maybe it's a bit about both, but the focus is clearly on security. So my name is Philipp Salvisberg. Oh, God. I have to stand here. My name is Philipp Salvisberg. I'm from Switzerland. I work there for a company named Trivadis. And you find further information on my blog, also the slides of this talk out there, links to my social media handles, etc. Feel free to contact me. That's about it. So let's get started. I have to push the time, huh? 2 minutes less. I plan to do an introduction into the topic, and I had prepared a live demo of about 20 minutes. So just bear with me. It will become a bit more interesting and in the style of a workshop, how this conference is called. Okay, so the first question is, what is PinkDB? Everyone heard of PinkDB already? Someone heard of SmartDB? SmartDB, someone? Someone heard of ThickDB? From the, always the same guys here? Okay, so it's not wrong to get some explanation. So what is PinkDB? PinkDB, I have to stand here probably. Huh? PinkDB is an application architecture. And it is based on the idea of SmartDB. That does not help you right now, but I will come to that point a bit later. So why are we talking about an architecture for database applications? The idea of this architecture is that it simplifies the maintenance of an application on the long run. That's one idea. Another benefit, if you do something like that, it improves your performance. And the third benefit, obviously, it makes your application a bit safer. And why is that so? PinkDB implements 5 features. The first feature is, if you have here the connect user, that's the one you use from your UI, let's say from Apex, to connect to the database, maybe also from your middle tier application to connect to your database. This user has no objects. So when you connect and do a select star from user objects, no row founds is the result. That's not the intention. And the second feature is when this connect user has only access to API objects. It's not possible to access something else, just the objects provided by an API. So you cannot have access directly to tables via select any privileges. It's not allowed. And an API, and that's the third feature, an API consists either of views or of PLSQL packages. That's the only way you get to your data, you process your data. That's the way how it is organized. And the fourth feature, it's very important one. PinkDB application uses the database as a processing engine. This means we try to use bulk processing. We do set-based statements, and in the end, we just avoid to do row-by-row processing. We don't want to suck out all the data out of the database, process it somewhere in the middleware, and push it back in the database. We want to do the processing in the database. And the fifth feature, and that's an important one, if you somehow cannot follow or implement all these features, then you have to document the exception why you cannot do that. For example, there are limitations in the Oracle database that does not allow to implement that. You have to grant somehow a table privilege to the connect user. A real case is, for example, AQ. If you use AQ for certain operations, the JMS driver needs access to the table. It's still so with the latest version, and then you have to do that. So exceptions are allowed. So I said it's based on SmartDB, but what's the difference? Good question. So I prepared 2 slides regarding the differences, and this shows the database features. When we look at the database features, we see PinkDB allows more database features, and SmartDB is more terse. So when you look at the Venn diagram, you see, okay, every SmartDB is automatically also a PinkDB application, but not the other way around. So that does not really help to understand what are the differences, but just the global standing. When we drill down and look at the allowed database features, the enforced principle, then we see something in the middle, in this intersection, which both have, and a lot of differences. So what do we have in the intersection? Both paradigms use the database as processing engine. And this is really an important feature. We use the power of the Oracle database. From my point of view, when let's say this is a feature worth 80% of everything we talk about. So we talk about the rest, the next 20%, and there the experts do not agree what's good and what's bad. That's just normal. But here, all experts agrees this is just good. So this is the same. So where are the differences again? And one difference is that SmartDB is defined that it allows only PLSQL packages. So if you use views, then it's not SmartDB. PinkDB allows views as an interface. And from my point of view, it makes sense. They are reporting tools that works with something that looks like a table. They are an Apex application. It's very easy to build application when you work with something that looks like a table. And views can exactly look like a table. You can even define constraints on views. They are disabled, but for documentation, the reporting tool has no idea that it is not enabled. You get the full feature sets like when we are working on tables. So it makes sense to use views. The other difference is SmartDB does not allow generated code. And from my point of view, and everything I say here in this talk, by the way, that's all my opinion. It's fair enough you have a wrong one, another one, but this is my opinion. So in my opinion, it's completely okay to use generators. For example, what I use table API generators when I have temporal tables. Temporal tables, you have to start from end to dates, and you have to ensure that there are no overlaps with the date ranges, that there are no gaps, and so on. And it's not that easy to ensure that on a table level. And for that, there are several generators around which can generate the fully working API for that. That's a table API. But table API gained a bad reputation because you typically also expose this API. But nobody says in a PinkDB application you're going to expose that. You can keep that as an internal API, wrap it with an X API, and expose this X API. So from my point of view, it's just more work, repetitive work when you disallow generated code, and therefore I don't like it. And another difference is that in SmartDB, the transaction control is in the PLSQL package. So if you have package procedures which do changes in the database, they have to execute the final commit or the rollback statement. If you don't do that, it's not SmartDB. And PinkDB allows the database transaction control outside of the database. An example, I have a Java application which does change 2 data stores. And I want to ensure that both changes are committed in a 2-phase commit, an XA transaction. So it makes sense to do the commit outside of the database in such an application. And that's allowed. And then you say at that moment, okay, let's peanut some minimal changes between this stuff called PinkDB and SmartDB. Is it worth all these definitions? And unfortunately, yes, because there is a very important difference between SmartDB and PinkDB, and that's the last one. SmartDB does not allow exceptions. If you violate one rule, then it's not a SmartDB application. So it's either fully 100% SmartDB or something else. There's a lot of discussion about this topic, and it is as it is. So this leads to the fact that I've never seen a real-life SmartDB application. That's a theoretical construct. It does not exist. If someone can show me something, I might change my mind. There are several people who tried that. It does not exist yet. So that's what I think. And therefore, we have something like PinkDB as an alternative, something that works in real life. And then there is something other important in this intersection. That's why I left some space here. And that's the principle of least privileges. And then we are back to the security track again. So what's that? Principle of least privilege, simply put, you just give someone an application, whatever, just that privileges that are absolutely necessary to do the job, nothing more. And why are we doing that? Because we try to reduce the attack surface on application. Because with introducing a privilege, we introduce automatically risk. And there's a lot of people trying to find out what you can do with certain privileges, and that's the security risk. And therefore, you try to minimize it. And one of the best known security risks in every relational database is SQL injection. And I guess every one of you have already seen that table, so just a check. Someone has not seen that one? Nobody. So we know that. What's a bit strange is this one. When you look exactly that when you want to inject something in SQL with a semicolon, it needs special code behind the scene to really execute the script, because the semicolon does not work in dynamic SQL. But it works when you have a REST API and some kind of SQL CL functions behind the scene, then this really might work exactly as it is exposed here. So back to some real-life code. And when we talk about security, we don't talk about flexibility. So I'm a developer, mainly a developer. And I remember the times when security was not a topic. And it became more and more a topic, and I did not like it because it makes my work a bit harder, let's face it. And I have code, and I still write code similar to that one, typically in migration programs. Typically, I do before they execute immediate some logging, where I log the statement I'm going to execute. Maybe it's also an anonymous PLSQL block that I execute. And I typically record the execution time, the number of records processed, and also get the full error stack and record that one. That's very convenient for me. But let's face it, this input SQL is the mother of all SQL injection. I don't have to inject it anyway. I just can pass anything and process it. So having such code in production base is just difficult, and just to somehow assert that SQL is not that easy. The easiest is to kick that out. So that's not the topic of this talk, but this is reality and we have to face it. There are other things, typically when we do dynamic SQL, or only when you do dynamic SQL. Here's an example of a drop table statement. We cannot execute the drop table statement in static SQL. That's just not working. It's not supported in PLSQL. So we have to use dynamic SQL. And we have to craft somehow the SQL to be executed. In this case, what I typically do is create some template and replace these placeholders. And in this case, the placeholder is replaced with the input parameter in table name. And that provides the ability to introduce SQL injection. At that point, somebody just thinks, introducing SQL injection in a drop table statement? Is this guy crazy here? What is he talking about? And I see, I agree to some degree. What you can inject here is you can pass a cascade clause, and then it drops all the related constraints, which would not be possible by design of this function. And what you also could do, you pass in a prefix of another schema and drop a table in another schema. And whether this works or not depends on the privileges of this user having this PLSQL code. So you can talk a lot, take a lot of time talking, arguing, is there really a SQL injection possible or not? But don't do that. My recommendation is don't do that. Just fix your code and assert it and make sure it's not possible to do a SQL injection. And this DBMS assert in quote just ensures that everything that comes in as a parameter is dealt with the table name. When you write something with semicolon spaces in it, then the table name must be named as that, and obviously it does not exist, and you get an error message. So this here, it's no SQL injection possible anymore. Then we have the other cases where we use dynamic SQL, where we could use static SQL. This is just happening because people say, yeah, we used the same concept with these placeholders in the drop table statement, and we do everything the same way, and blah, blah, blah. So that's a reason to do that. But here again, you're also introducing SQL injection. It's possible to pass in a DName, and it will become part of the SQL and execute it directly. Here you don't use, to fix that, you don't use an assert. You just do use a bind variable. And by using a bind variable, it's not possible to do SQL injection. For the table name, it was not possible to use that as bind variable, but here it is. And when we go a step further, when we develop stuff in the Oracle database, and the Oracle database is really one of the main features that we have static SQL within it. So we can write it with less lines of code, and it's automatically secure. And the advantage is if you do that this way, you just can be sure if you had static SQL, SQL injection is just not possible. There's no way to do SQL injection with static SQL. And that's a great advantage when you think about security. What's happening with switching this screen? Okay. There's no feature on that device to do that. It happens automatically. Where was I? Okay, there's no way to do SQL injection, but it has another advantage. You write less code, and you get more information in the Oracle Data Dictionary. You know that this sum cell function is using the emp table. You know that this sum cell function is using these columns. These are documented in the data dictionary. With PLScope, you can query that and get this information. It's just an advantage. There are some cases where it's really helpful to use dynamic SQL, but these are exceptions and not part of this talk. Good. So at that point, you should agree to some degree that it makes sense to invent some application architecture applied in the database for security reasons and other reasons. So how do we find violations of something like that? And I converted the well-known depth emp application, part of the Scott demo schema, to a PinkDB application, and I added also some utPLSQL tests to check properties of the PinkDB and to check if there are some violations of the principle of least privileges. How does this application, how have I converted it? So I use this diagram again. I have in the middle here the data, and it's no surprise that the data is the depth table and the emp table in a new schema called app. That was formerly, it's exactly the same you had in the Scott schema. And now we come to the API. How does the API look like? I introduced there a view layer. In this case, it's just the read-only view layer for departments, for employees, and something combined. And there is a write-only for write operations on the data. There are packages for department and API. Don't think about it as a table API. Think about it as a transactional API, as an X API. And there's something very important I tried to highlight it here with app. Both these things are installed in the same schema, in the app schema. There is this misconception that the data should be stored in a dedicated schema. That's of course possible, but you have to think about what are you gaining when you're doing that. It's a pain, really a pain when you have to grant everything from this data schema to this API schema. So what do you gain? And usually you don't gain much, basically nothing. So in that case, you shouldn't do that and put everything in one schema. And the API is just protecting that stuff. And the API is the stuff you are granting to the outside world. And the outside world is, and there we need an additional Oracle user. It's the connect user. And in this case, I called it the app connect user. It does not own objects. It has the right to create the session, and it owns a role for the API objects. That's everything. That's it. So I used about 20 minutes. So the next 20 minutes I plan to sit and to show you something. The first thing, maybe you saw it, all these examples are available as a Git repository. I explained them also there. So after the session, you have the possibility to check that out yourself. And part of the first thing I want to do is just to install the application and to show you some things here. The installation process works this way, that it calls just a set of scripts, and this is also created in a way that it is rerunnable. So I can change certain things and it will be applied automatically. So let's look at something I have not explained previously. We also have developers, and they like to develop in a certain way. So I show the script. So how it is created, because everything is rerunnable. Maybe I have to do that a bit larger. Maybe it's rerunnable. I do here everything with dynamic SQL. I talked a lot about static SQL, but here I use it. Because basically what I want to do is create user if not exists, and starting with 23C we can do that finally, but right now with 19C it's not possible. And what I do here also, I grant create session to developer. I grant the API role to the developer. That's the same as a connect user. But I do something interesting here. I give the developer user the right to become an app schema. And that's finally to be a proxy user. How does that work? I demonstrate that. I connect here. And I show here that I'm connected as user app, but there is also a user environment variable which tells you that the authentication happened as a user developer. And when I look here, then I see the tables. I'm the app schema here. I see the views, the indexes I see of course too. And I see the packages, and I see also here test packages. And the interesting thing is here, probably, how do I connect to become another user? It's just the normal credentials here, everything as the developer. The only difference is here in square brackets, I use app. Who is using proxy users in their world? It's not a widely used feature, but it's quite cool, I think. And it's quite cool because of another thing I just forgot to show you when I open here the script for the app user. Did not work. It's, yeah, I cannot concentrate when Camille is doing photographs of me. Yes, and that's what a very bad remark from my side. So what I wanted to do, exactly the app user. When I see here the app user, this one was created with no authentication. So it's not possible to connect as app user. There is no password for that. It's possible to connect via DBMS job or scheduler where you don't need the password, but otherwise it's not possible. The advantage is you don't have to maintain a password and tell the team what the password is. Every team member can connect us with their own user, with their own credentials. And guess what? How long do you think is this feature available? When was it introduced? In which version? Anyone wants to guess? Version 9, absolutely correct. And since version 10, SQL Plus fully supports it. And it's no driver available that cannot use these bracket syntax to connect. So it's really safe to use it. It's an old feature. Just this no authentication clause was introduced in 18C. So that's the new stuff. Okay, so that's about the setup. I close these files here, I don't need anymore. And since we have some tests here, I execute them via utPLSQL. So the utPLSQL framework runs, and I see I have executed 26 tests. Some of these tests are regarding PinkDB. Some of these tests are regarding the API, regarding the view layer, and some of them are regarding the packages APIs. It's quite boring because everything is green and we are fighting bad application, and this is a good one, so it's no fun. Huh? So we have to install some bad things, and the script reveals the name, install bad stuff, okay? So it should be clear what it is doing. So we install that. Just look what I've installed here. I, for example, brought any table to the app. That's not good. And that's common, huh? DBA to the app connect, because, yeah, you know, just in case we run in some problems, then we can solve them ourselves. And then we grant all privileges on emp to the connect user, and we do something very nice. We grant DBMS SQL to the app connect user. This is, from my point of view, is the most powerful package procedure in the Oracle database, because what you can do is you can run arbitrary SQL or PL/SQL code as any user you like. So if your DBA doesn't give you the rights, you say, okay, I'm fine, just give me one procedure access and I'm happy. So then ask for that one and you're safe. We do the bad stuff here also to grant it to the API role. You want to make a photo? Have it? No, okay. Okay, good. Then we do the bad stuff here also for the app role. I grant here the depth table to the role, and also this bad procedure there. And then we create some table in the app connect user, and at the end I do something nice. I implement an alternative package which allows SQL injection. So this was the bad stuff. And we have our tests here. I've installed it, so let's just rerun our tests. And nicely, I have 7 failures. In this presentation, I like it. Usually, I don't like it that much. But we just concentrate here on the failures. 5 of them in the area of PinkDB, and there are also some failures in the API. We just walked through these things. The first failure I have in a test called app schema privileges. And these app schema privileges expect exactly these privileges. But it got an additional one, select any privileges. So this is nice. And how did, and this is based on utPLSQL. Who uses utPLSQL? Ah, with Nora, that's cool. I'm really happy to hear that. And one of the cool features of utPLSQL is that you are able to compare cursors. And that's what I've done here. I had here a cursor that gives me all privileges of a user, and getting all privileges is not that easy because we have roles that can be granted to roles and roles that can be granted to roles. We have object privileges and everything. And there's a query, and I'm typically a fan of writing a bit fancy, complicated query that does everything. So it's just a cursor that gets you that stuff done. So I use that here, and I have revealed that we have too many privileges here. The same for the connect user. Remember, the connect user got the DBA role. And the DBA role contains really a lot of privileges. When I just open it up here a bit more than I see, we have 241 privileges and 239 differences because I expected just 2, and just the first 20 rows are found. So you see, when you get DBA rights, you get a lot of privileges. And the next difference we have here in the user objects, there's revealed that we have here a table found there, direct privileges, this thing that we have access to. I open it up here again. That we have here direct access to the emp table with various privileges, and also this very bad stuff here with DBMS SQL. This is all revealed. And the last thing, similar for the API role, where we have also access to objects which we do not expect. We expect that the API does not expose tables. That's checked here. And we expect that the API does not expose objects that are owned by another schema. In that case, you should create a separate role and manage it there. So that's the things about PinkDB. And then we have some failures regarding SQL injection. Usually you don't write SQL injection tests. This happens in real life when you detect a SQL injection, then you can write a unit test for it to see, it's really possible to do a SQL injection, and then you try to fix it. So let's imagine somehow this way these tests are happened here. And what we try here is we just want to set the job to S, and we want to set the salary to 9. And what utPLSQL has found out, yes, the actual value of job is S and the salary is 9, and we expected that this is not possible, so that the whole string is would be treated as the job name. So this would be stored in the Oracle database as job. That's what I've highlighted here. And it was not that way, so therefore it's really SQL injection. And we use these 9 characters which are available, and therefore the other test is a bit more significant. Usually your application has constraint to ensure that the job name is really existing, and it doesn't really help if I can add, change the job to 9 from 3,000. It would be much more helpful if I could increase the salary, so from a colleague, something like that, huh? And then we drink a beer together. So this was the second test here that failed. It was possible to change the job to salesman and change the salary to 9,000 with SQL injection. But what we expected here in this test is that we do not get at this position. When we reach that position, something went wrong. We expect that we get a failure. And what failure did we expect? That's here. We expect that the value error is thrown. That's PLSQL exception, or that when we insert something in the table, the Oracle database says, hey, that's 19 characters. It does not fit in these 9 characters we have stored there. So this did not happen, and therefore we got these exceptions. Okay? So you see we can detect that here. But usually, as I said, we don't write unit tests for SQL injection. It's just not feasible to do something strange. What we typically can do is we run some linter, some code analyzer to search for SQL injections. There are several products that are able to do that. I've installed here a linter, dbstar CodeCop, and this is able to find here the SQL injection vulnerabilities. So this is a tool that can help you, and this tool you can run just on plain files. It does not need to have a connection to the database. So in the abstract, if someone has read the abstract, I say, how can you apply something like that in a CI environment? I have here a mini CI environment. I could have set up a Jenkins, but I think it's easier if I just show you everything in a single shell script, what I would run in a CI environment. And I start that because that takes some seconds to complete. And while this runs, I explain what I do here. First of all, I start utPLSQL. There's a command line utility to run utSQL with several output options. I used a lot of them here. And we see here the variant is, we see here also the tree. Some of these tests have failed. All of the tests regarding PinkDB have failed. And I get the similar output that you've seen previously in SQL Developer. So that's what I get here. And the very end of the script, I run Sonar Scanner. That's a product that allows you to scan code of various programming languages, and PLSQL is one of them. I run that product that analyzes all these files, and at the end I get a link where the result is stored. So I call that one. And I get here a nice dashboard. And this dashboard shows me I have 2 vulnerabilities. I will click on it in a moment. It shows me I have 44 code smells. It estimates, it takes about 2 hours to fix all them. I have 19 unit tests, 60% code coverage, also some code duplication. So let's look at the vulnerabilities. And I see that the same code here is detected as in SQL Developer. And when doing that in a CI environment, you have the advantage that you can define some quality gates and say, hey, when I don't have a security rating of A, it's not possible to merge my code in the target branch. Let's say it's maybe a develop branch or main branch. You just say it's not possible. You have to fix these vulnerabilities first. So you can automate that stuff. So let's look. And the advantage I very much like SonarQube because you can look at the code from various angles. It's like a data warehouse application for code. And here we see the source directory and some metrics. Just concentrate here on the metrics vulnerabilities and code smells. You see 2 and 44. And when I drill down here, I see in the test package there are no vulnerabilities and code smells. I click here in the main, and I see this seems to be okay, and everything seems to be in the packages, and these packages seems to be okay, but there are in the alternatives all this bad stuff, and is located. And this package we looked at before, and this is a fixed variant where we fixed this vulnerability by just asserting the column name and using bind variables, and therefore we don't have detected any vulnerabilities anymore. I just show something small also here, that at the set procedure we have a lot of code smells. And usually this is one of the rules I disable because I think it's just too much work. You will see it why. It says, it's possible to pass an in job. It's defined as varchar2, and even if you do a person type, you can pass in 32,000K string. It works. And you should assert that and check if it is not longer as these 9 characters. And how can you do that? There's an implementation of that in the good code. When I look here at the set job, how can you do that? There's the same in, assign it here to a constant. This job is defined based on emp job type and assign it that value. It's really painful to write that many code, but in this case, you get a value error. And what's also interesting is, it's not possible to catch this value error in that block. The exception is raised in the caller, so it becomes the responsibility of the caller. What we see here also, everything is green, that's the code coverage, because all tests have covered our code, that's quite good. And this brings me to the last thing about the tests. When I go back to the dashboard, I can click here on the unit tests. I find all 19 unit tests, that's nice. I also see here that 7 of them have failed. But there's a flaw in SonarQube. Actually, it was good in earlier versions, but in current versions, there's a flaw. I see that some of these tests have failed, but I have no further information. If I want to see them, I get this information typically in my CI/CD environment, and it will look something like that. You get this information about which tests have failed. And again, you have the possibility to define in your environment, if there are failing tests, it's not possible to merge in the target branch. So that was the demo. And I come to the last slide, to the key messages. And as you heard, everything counts. Depeche, I called it always the Depeche Mode principles regarding performance. And we have the other tracks there's regarding performance. And when we look, or when we are fighting bad database applications with the context of performance, we look at everything counts in large amounts. So we get this bill, the top contributors at runtime, and we try to solve them. We don't look at all the other stuff. It's not interesting, even if I manage to get the 0-second response, it doesn't have enough impact, so I don't do that. I just focus on the top stuff. So it's just in large amounts. And the difference, in my point of view, to performance is that in security, just everything counts. Not just in large amount, just everything. It's the thing of the principle of least privileges. You really have to think about to lock down your application. Even there are possibilities, think about which privileges do you read at runtime, which privileges do you need at design time, at install time, and if you think about it, they are different. So if you really focus on that one, could be a next talk, there's a lot to do. And there are other similarities with performance and security. You can just react when it happens, when the performance is bad, you look at it and try to fix it. And in security, you can do the same thing. Maybe the house is burning and you try to the firefighters fight that fire, and sometimes they succeed, and sometimes, bad luck, the house is burned down. And then the similarity again is you can learn something about it and design your database application accordingly. Kerry Millsap, since years, is telling us that performance is a feature of an application, and with security is absolutely the same. So, and I hope I showed you that the Pink database paradigm could be an approach for performance by design and also for security by design. I hope some of you can take some ideas back to home. And yes, I'm almost finished. If there are some questions right now, I may answer them too, maybe. Someone a question? If not, thank you very much.